In today's class and video, we are going to look at how to pack the column in column chromatography. So we'll start our introduction by looking at the glass column. And this is the picture of the glass column used in the column chromatography. And this is the stopcock of the glass column, which is used to control the rate of flow of the mobile phase in the column. So the glass column in common chromatography is a vertical cylindrical glass tube with a stopcock used to hold a stationary phase through which a sample mixture dissolved in a mobile phase is passed, allowing the different components of the mixture to separate based on their different affinities for the stationary phase as they travel through the column. And the glass column is typically made from chemically inert borosilicate glass for easy cleaning and reuse. So let's look at the steps for packing the column. So the first step is to prepare the slurry. And to prepare the slurry, we mix the stationary phase with the mobile phase to create a thick paste called slurry in a beaker. So example, if you want to prepare a silica gel slurry, you can weigh about 10 grams of the silica gel 60 and add to 40 ml of the mobile phase solvent and stir to create a thick paste of the silica gel slurry. So the next step is to fix the column in a vertical position with a clamp and place a beaker under the column outlet as shown in the picture over here. So then the next step is to plug the column, and to do this we plug a small piece of glass wool. So this is a glass wool over here, or cotton wool, at the bottom of the column to prevent the slurry or the packing material or the stationary phase from leaving the column. And when we are done with that, the next step or the next thing to do is to place a small amount of chromatography sand on top of the glass wool or cotton wool to give a nice surface level of the stationary phase above the glass wool or cotton wool. So this is a thin layer of a chromatography sand placed on top of the glass wool or cotton wool in the column. So the next step is to open the stopcock of the column, and the next is to pour the slurry into the column. So to pour the slurry into the column, we must carefully pour the slurry slowly to about 2/3 of the column length with the stopcock open to elute excess solvent from the column and allow the adsorbent or the stationary phase to settle well under gravity. So what we also have to note is that the opening and the closing of the stopcock, so this is the stopcock over here, helps to control the rate of flow of the mobile phase in the column. And this is a picture showing how the slurry is being poured into the column carefully. So let's look at how to calculate the 2/3 of the column length in the column chromatography process. So assuming this is the column that we are going to use for the column chromatography process, with a total length from the base to be 60 centimeters, 2/3 of it will be given as 40 centimeters, and this will be 2/3 times the 60 centimeters, which will be equal to the 40 centimeters over here. So what it means is that the 2/3 of the total length of this column will be at the 40 centimeters mark. So what it means to pack the column with the slurry to about the 2/3 of the column length is first to find or calculate the 2/3 of the column total length and pack the column with a slurry to that mark or length. So from this picture, we can see that the stationary phase or the slurry is being packed to the 40 centimeters, which happens to be the 2/3 of the total length of this column. So let's note what we have to note when pouring the slurry into the column. So one is that we pour it down a glass rod held against the walls of the column to minimize bubbling and turbulence. And two is to tap the sides of the chromatographic tube or column continuously and gently with a policeman or a rubber stopper or tubing to help the silica gel settle uniformly or compact in the column, and also to remove air bubbles. So this is a policeman or a rubber stopper or tubing which is being used to tap the sides of the chromatographic tube or the column as shown in this picture to help the silica gel settle uniformly or compact in the column, and also to remove air bubbles. So after packing the slurry into the column, the top of the packed stationary feed should be lined with filter paper disc or a chromatography sand to protect the surface of the stationary phase whilst the column is being loaded with a sample or the eluting solvent. And finally, we are to allow the solvent level above the stationary phase in the column to drop to about 1 to 2 mils above the filter paper disc or the chromatography sand as shown over here. So let's now look at what the statement "the column must never run dry" means in column chromatography process. So let's first study the setup or the picture here to understand what the term means in column chromatography. So the setup here is a picture that shows the chromatography process in column chromatography with the glass column being clamped vertically with a clamp and the bottom of the glass column plugged with a glass wool and a chromatography sand as shown over here. The column is also packed with silica gel as the stationary phase and loaded with plant extracts to cause the separation of the various plant pigments in the plant extract as bands of different colors shown here. And as this process is carried out, the mobile phase solvent is made to be above the stationary phase in the column continually to ensure the column is kept wet during the chromatography process. So the statement "the column must never run dry" in column chromatography means that the solvent level within the column should always be maintained above the stationary phase during the chromatography process to prevent the stationary phase from drying out as shown in this setup. The drying out of the stationary phase causes cracks in the packing material or the stationary phase, leading to uneven separation and poor results in the chromatography process. So it is important that the column should always be kept wet whilst in use by not allowing the solvent level to drop below the top of the stationary phase in the column. So these are pictures of poor separation due to cracks in the stationary phase as a result of poor packing of the column or the column being made to dry out or run dry during the chromatography process. So these are the pictures. So this is the first picture, the second picture, and third picture. And these are all poor separations in the column chromatography process. So these are also pictures of good separation due to a well-packed column and the column being kept wet during the chromatography process. So as you can see, so this is a well separated bands of different colors over here as seen over here, and this is also a well separated bands of different colors, and this is also a well separated bands of different colors as a result of a well packed column and the column being kept wet during the chromatography process. So let's look at the two common ways of packing the column with the stationary phase in column chromatography. So the two common ways of packing the column in column chromatography are: one, the dry packing method, and two, the wet packing method. So let's start by looking at the dry packing method. So the dry packing method involves adding the dry solid phase of the stationary material directly into the column and later adding the mobile phase solvent to it. So this is the picture showing how the dry packing method is done. So where the solid phase of the stationary material is directly added to the column before adding the mobile phase solvent to it. And this method is simple to perform, but the disadvantage is that it can easily result in uneven packing, especially with fine particles if not done well. So the second is the wet packing method or the slurry method. And in the wet packing method or the slurry method, the solid phase of the stationary material is first mixed with the mobile phase solvent in a beaker to form a slurry before pouring into the column. So from this picture, we can see that this is our prepared slurry in a beaker being poured into the column. And this is also a prepared slurry in a beaker being packed into our glass column as shown in this picture here. So basically, this method is generally considered the preferred method for achieving more even and efficient packing in the column chromatography process.